Hello everyone, I am V. Kavita pursuing my MSc at Physics at RIE Mysore. In this session, we are going to discuss about CA, AN, CN transition. In this session, we will be covering the introduction, characteristics of CA, AN, CN transition, applications, influence of external factors on transition, and will conclude. Introduction to Ca, An and Cn transitions in liquid crystals. What are liquid crystals? Liquid crystals are unique states of matter that exhibit properties between those of conventional liquids and solid crystal. The transition between different liquid crystals phases such as Ca, An and Cn are crucial for understanding their behavior. As you can see here in this picture, this is for crystalline solids, liquid crystal and isotropic liquid. This Ca, An and Cn transition in liquid crystals refers to specific phase transition that occur between different states of molecular arrangement in the material. Let me explain each transition. The Ca transition in liquid crystals refers to the transition from the cholesteric phase C to the symmetric A phase A. It's a change in the molecular arrangement of the liquid crystal. As you can see in the picture, the Ca transition involves a change from a crystalline solid-like structure to an amorphous liquid-like structure in a liquid crystals. This transition typically occurs at a specific temperature known as the clearing point. During the Ca transition, the long-range order of the crystal structure is lost, leading to increased molecular mobility. Then what is cholesteric phase? Cholesteric phase is nothing but the molecules are arranged in a helical structure, forming layers that twist around a central axis. This twisting structure gives cholesteric liquid crystals their unique optical properties such as selective reflection of light at specific wavelength. You can see the picture in next slide. And during the Ca transition, this helical structure of the cholesteric phase unravels and the molecule organize themselves into the layers. These layers are more orderly and parallel to each other compared to the twisted structure of the cholesteric phase. The Ca transition can be induced by factors such as temperature, pressure, or the presence of certain substances. Understanding and controlling this phase transition is essential for the development of liquid crystal based on technologies including displays and optical devices. I hope that clarifies the Ca transition. Now, Cn transition. Here, Cn transition refers to the change from a crystalline phase to a nematic phase in liquid crystal. The nematic phase is characterized by orientational order but lacks positional order, making it distinct from the crystalline phase. The transition from a crystalline to a nematic phase occurs at a lower temperature compared to the Ca transition. The Cn transition in liquid crystals refers to the transition between the cholesteric phase and the nematic phase. In the cholesteric phase, the molecules are arranged in a helical structure. Just now in last slide I explained. You can see in this picture. And it forming layers that twist around the central axis. This twisting structure gives cholesteric liquid crystals their unique optical properties such as selective reflection of light at specific wavelength. During the Cn transition, the helical structure of the cholesteric phase unravels and the molecules align themselves in a more random and disordered manner. Similar to the nematic phase, in the nematic phase, the molecules are oriented along a particular direction, but they lack the layered structure and helical twisting of the cholesteric phase. The Cn transition can be induced by factors such as temperature, pressure, or the presence of certain substances. Understanding and controlling this phase transition is important for liquid crystal-based technologies, including displays and optical devices. Before going to the An transition, we'll discuss about Ni transition. The Ni transition, also known as isotropic transition, involves the conversion from a nematic phase to an isotropic phase in liquid crystals. During this transition, both orientational and positional order are lost, resulting in a disordered fluid-like state. The Ni transition typically occurs at a higher temperature compared to the Ca and Cn transition. From this graph, we can see that isotropic nematic phase transition through cooling for different isobars. The number density n, you can see here n, and the nematic order parameter S2 are plotted versus the temperature T for different pressure. Now, AN transition. In AN transition, in liquid crystal can be induced by various factors including changes in temperature, pressure, and the presence of certain substances. Temperature plays a significant role in triggering the AN transition. That is, increasing the temperature can cause the molecules in the symmetric A phase to gain enough energy to break their layered structure and transition into the more disordered nematic phase. And pressure can also influence the AN transition. How it will influence the AN transition? By applying the external pressure to the liquid crystal system, can alter the molecular arrangement and disturb the layered structure, leading to the transition from the symmetric A phase to the nematic phase. Additionally, the presence of certain substances called dopants can induce the AN transition. These dopants can interact with these liquid crystal molecules and modify their organization, causing the transition from the symmetric A phase to the nematic phase. What are the characteristics of Cn, An and Cn transition in liquid crystals? During the Cn transition, the liquid crystal molecules change their alignment from a helical structure to a more random orientation. This results in a loss of the helical ordering and the formation of a uniform director field. The Ca, An and Cn transition in liquid crystal are reversible processes that depend on temperature and pressure. During AN transition, the liquid crystal molecules change from a layered structure to a more disordered arrangement. The molecules align in a parallel fashion, but without any long range or positional order. These transitions are accompanied by changes in molecular interactions and physical properties. In Cn transition, the liquid crystal molecules change their alignment from a helical structure to a more random orientation. This results in a loss of the helical ordering and the formation of a uniform director field. Understanding the mechanism behind this transition is essential for designing advanced liquid crystal materials for various applications. Examples of each transition in liquid crystal. First one is cholesteric to symmetric A, that is Ca transition. Example, when a cholesteric liquid crystal material is heated, it undergoes a Ca transition. Example is when a liquid crystal thermometer changes color as the temperature increases, the twisting layers of the cholesteric phase unravel and the material transition into the ordered layered structure of the symmetric A phase. And second one is symmetric A to nematic, that is AN transition. When a symmetric A liquid crystal material is cooled, it undergoes an AN transition. And example is the transition that occurs in liquid crystal displays. As the temperature decreases, the outer layers of the symmetric A phase break down and the material becomes a nematic liquid crystal with molecules aligned along a particular direction. And the last one is cholesteric to nematic, that is CN transition. The CN transition can be induced in cholesteric liquid crystals by applying an electric field. Example is the use of cholesteric crystal in reflective displays such as e-readers. By applying an electric field, the helical structure of the cholesteric phase unravels and the material transition into the nematic phase, that allowing light to pass through a creative and reflective display. This example illustrates how different transition in liquid crystal can be utilized in various applications. More applications we'll learn in next slide. The applications of the CA, AN and CN transition in liquid crystal technologies vary depending on their properties and characteristics. The unique properties exhibit during CA, AN and CN transitions make liquid crystals valuable in the display technologies, optical devices and sensors. How display technologies works? Displays used in cholesteric liquid crystal displays for applications like electronic shelves labels and e-books due to their bistable nature and low power consumptions. And how optical devices works? Optical devices used in employed in optical filters, color changing materials and reflective displays. For sensors, you can see the picture here. And liquid crystal displays utilizes this transition to control the passage of light and produce vibrant images. AN transition. For AN transition, display works as relevant in certain liquid crystal display modes, though less common compared to the CA transition. And material science used in the study of liquid crystal materials and their phase transitions, providing insights into their properties and behavior. For CN transition, displays can impact the performance of cholesteric liquid crystal displays, affecting their affecting their optical properties and response times. Optical devices utilized in devices where the maintenance of chirality is not critical, such as variable optical attenuators and tunable filters. Emerging application in smart windows, tunable lenses and adaptive systems can also leverage the properties of liquid crystals. This transition plays a crucial role in designing and optimizing liquid crystal based devices for various applications in displays, optics and material science. Influence of external factors and transition. External perturbation can cause significant changes in the macroscopic properties of the liquid crystal system. The order of liquid crystals can be manipulated by mechanical, electric or magnetic forces. Here, external factors such as electric fields, magnetic fields and surface treatments can influence the CN, AN and CN transmissions in liquid crystal. How it's affecting, we'll see. Here you can see the figure, electric and magnetic field effect. Due to the effect of electric field, permanent electric dipole results which aligns the director along the electric field. The effect of magnetic field is analogous to the electric field. And surface preparation, it is possible, however, to force the director to a point in a specific direction by introducing an outside agent to the system. For example, when a thin polymer coating, usually a polymer, is rubbed in a single direction on a glass substrate with a cloth, it is observed that liquid crystal molecules in contact with the surface align with the rubbing direction. By applying external stimuli, researchers can manipulate the phase transition and highlight the properties of liquid crystal materials. By understanding the interplay between intrinsic properties and external influences is crucial for optimizing liquid crystal performance in various applications. So now we'll conclude this session. Here what we learned in this session, CA transition, AN transition and CN transition. What is CA transition? It refers to the cholesteric phase to the nematic phase. It is characterized by the loss of chiral order. You can see here loss of chiral order, that is molecular order. Here transitions are 5 types: phase involved, molecular order, orientation, temperature range and applications. We learned right in this session. Here characterized by loss of chiral order and the AN transition is loss of layering and CN transition is no change in chirality. For phase involved, it is cholesteric phase. For AN transition, it is symmetric phase. And here CN transition, it is same cholesteric phase. For orientation, CA transition is helical structure. For AN transition, it is layered structure. For CN transition, it is no specific orientation. And in temperature range, CN transition typically occurs at lower temperature and AN transition occurs at higher temperature and CN transition occurs at various temperatures. Applications of transitions. For CN transition, it is widely used in display technologies and AN transitions is relevant in liquid crystal displays. For CN transition, its impact on liquid crystal properties. So, each transition involves different molecular arrangements and properties within the liquid crystal material. So, that will be the end of the discussion. Thank you.